We're expecting more people, but whatever. Let's just start. A bunch of rounds to get through. Try to get to them quickly. If you miss anything, hopefully you can answer the questions quickly and then run through and then go over the videos for anything else that you need. So again, you're going to need to know how to differentiate a bunch of stuff. So let's start with A. How do you find the derivative of this? Product rule. We have one function times another function. There's multiplication. So how does it work?
But you don't use the chain rule because there's no parentheses, right?
F prime G.
We will need the chain rule to do this.
No.
We will.
Okay.
We do.
F prime G plus F G.
Right. The derivative of f times g is f prime g plus f g prime. So we differentiate this, you get 1, leave this guy, plus leave the first one, and you differentiate this guy with the chain rule.
2 sin x cosine x.
How does that work?
Wait, you take the power down.
Differentiate the outside function first. It's not sine of x squared.
Didn't you say that you have to do the chain?
Yes, we still have to do the chain.
Cosine x squared.
You have to know, if someone tries sine x squared, this means sine of x squared. If you put the 2 here, that means this. They're very different. So now what?
So it's cosine.
Differentiate the outside function, leave the inside intact, then multiply the derivative of the inside.
So what's the second case? What would it be?
The second case,
Like if it was sine of x.
Well, he does what he said.
if your y were x times sine squared x, then your derivative would be sine squared x plus x times 2 cosine x. Sine 2. Well, then put it in order. 2 sine x cosine x. Right? Because that's when you think of this guy as sine of x all squared, so you bring the 2 down in front, multiply by the derivative inside.
We need to know all the different derivatives of like tangent and cosecant and stuff like that.
Yes. So derivative tangent, secant, cotangent, all the trig functions you need to know. Obviously for polynomials you need to know. But yeah, they ask you about various trig functions.
Oh, so there was a lot of trig on it?
Yep.
And the values of them as well.
Yes. This one?
Do the product rule and the chain rule?
Product rule again with the chain rule in both parts. Okay, so how do we do this? Differentiate the first one. What do you get?
6x.
Right. And then you leave this one alone. Plus, leave the first one alone. Times differentiate this one. Questions on that?
That's it?
Well, no, you have to simplify.
Oh, okay.
So how do we simplify?
Take out the
Take out the common factors. Right, so x is a common factor. Do we have any constant common factors? Yes, 12 is one.
Dx squared minus
Then we have 3x squared minus 2 to what power?
2.
To the third power. We have 5 minus 4x cubed to what power?
4.
Fourth power. You always take out the lowest power. Now we write what's left inside. So 4 times 6 was 24. I factor out 12, so I just have a 2 here. This I took out everything. Here there are 5 of these guys we multiplied. I took out 4 of them, so it's just 5 minus 4x plus
3x squared.
this guy. I took out 3 factors, so there's 1 factor left. 5 is left.
-1.
Took out all of these. Just minus 1. This guy would be 10 minus 8x cubed. This would be minus 15x squared plus 10. And so this would be minus 8x cubed.
Is it negative x? Since it's on the first one, it's at the end of the first line, it's negative 12x squared. And then you took out like 12x.
I took out 1x, right? So this is actually, this was a square here. So that would be cubed and 10x, right? So we have minus 8x cubed minus 15x cubed. So that would give us minus 23x cubed plus 10x. So this is comparable. This is sort of what I was talking about when I said challenging. It's like the concepts are there, but this is what the problems would look like, you know? So you have to sort of prepare to be focused and get all these problems. How would you differentiate that?
The product line?
No.
Plus
Chain rule. Chain rule twice,
Yeah.
right? So there's chain rule because the sign itself is squared, and then you have to do a chain rule because the angle inside the sign is squared. So chain rule on the outside, 2 sine x squared times cosine x squared times, now the derivative inside.
Wait, what's cosine x?
The derivative of sine. Right? It's like you think of it as sine x squared squared. And so when you're differentiating, this 2 comes down in front, the inside stays intact, power becomes 1. You multiply the derivative inside, right? So that's just cosine of x squared, the derivative of the outside function, and then you multiply by the derivative of that again. So again, you're still just applying the chain rule, but it's really annoying applying it several times. That's sort of what the final is going to be like. Minus, again, differentiate the outside, which is the cosine. Derivative of cosine is minus sine. Leave the inside intact, then multiply by the derivative of the inside.
Also, sine is the angle of cosine. Sine x.
Sine x is the angle of cosine, yes. Plus,
2 cosecant squared. No,
Tangent.
Secant squared. No, yeah, secant squared.
Secant.
X cubed.
It's cosecant squared.
Which is tangent of x.
2 tangent of x cubed times, what's the derivative of tangent?
Cosecant squared.
Secant squared.
Secant squared x cubed times differentiate the angle.
Wow.
4x sine x squared cosine x squared plus cosine x.
So then you want us to simplify everything?
Well, this one can't really simplify a lot. We'll just write down the pieces a little bit nicely.
So let's say over there, in the last question, let's say that was a quadratic equation. Like, let's say that was negative 23x cubed plus 10x plus 10. Would they want us to simplify that?
No, don't have it. And again, if it helps you, you can just, write this down as that, right? And it's sort of more manageable. Because you can see here that this is the inside, so you differentiate the outside, the 2 comes down in front of the tangent is there. Then you multiply the derivative of the inside, derivative of tangent is secant squared. Leave the inside intact, then multiply the derivative of the inside.
Write that as 1 minus x squared to the negative 1/3. So you don't have to do that.
Right, I can write it as 1 minus x squared to the minus 1/3. So now what's the derivative?
Minus 1/3 times 1 minus x squared to the, see subtract negative 3/3. So it's negative 4/3. Then times negative 2x.
Right.
Plus 4 times x squared minus cosine 3x. That's a third. Times 2x minus sine of 3x times 3 plus cosine of 2x times 2 plus 2 cosine.
Cosine 2x times 2. Okay.
Wait, minus 2x doesn't have a exponent?
What, right here?
Yeah.
No. It's just the derivative of the inside chain. So this is 2/3 x times 1 minus x squared to the minus 4 over 3 plus 4 times 2x minus 3 sine 3x times x squared minus cosine 3x cubed plus 2 cosine 2x.
Yeah, that's the corner one.
Wait, on the final, the work is rated, right? Do you look at the work that you've shown here?
Yes.
So does it count where you put parentheses and all that?
Well, I was sort of OCD with parentheses. I don't need as many as I put, but yeah.
What? We need
Like these parentheses, important.
Okay.
This is not so important if you put a dot here. These are important. This is not so important. I didn't want to mix myself up and multiply the 3 by the angle. Right? It's the whole sign times 3. Right? So I just put these parentheses to emphasize that. Right? You can never take something outside and multiply the angle of a trig function. So just to emphasize that this number here has to stay outside. That's why I put this in brackets. But technically I didn't have to.
As long as the next step is correct.
Yeah. That was problem 1.
Oh, wait, you don't have to simplify further?
No.
I mean, if you can, like, each one has like a 2 in the beginning. Okay, would you simplify?
Probably, but only if like you have a lot of common factors that are functions. Like none of these functions are really.
But if it was all, like, you see where the 4 is and 2x, 2x, 3, things like that, would you simplify? It's not 4. Okay.
This is. So this was a problem from the book. Find the first and second derivative. Do the quotient rule, which says what?
F prime g minus f g prime over g squared.
Right, where the top is f, bottom is g. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Before finding the second derivative, I would recommend we simplify a little bit. Can we simplify anything?
You can take out 4t cubed and
4t cubed, we'd be left with t to the 4th plus 1 minus t to the 4th plus 1.
minus 1. No, only 1.
Can't you cancel one of those?
Don't think of canceling across sums, that's blasphemy, you can't do that. So t to the 4th minus t to the 4th, so this is just a 2 in here, so this is really just 8t. It's plus, right? It's minus and minus. And so we have t to the 4th plus 1. So that would be the first derivative. Second derivative, you do the quotient rule again, right?
24t squared times t to the 4th plus
Right. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. To the 4th plus 1, so now this is to the 4th power. Any common factors? Yes.
24t squared.
Can I take out a 24?
Oh, sorry.
No.
8t
I can take out 8.
squared.
I can take out 8t squared. I can also take out t to the 4th plus 1 to the first power, right? I'd be left with here t to the 4th plus 1 times 3 minus here I'd be left with t times 2 is, yes. And in here, what I have is 3t to the fourth plus 3. This is just minus 8t to the fourth, right? So I have 8t squared, 3t to the fourth minus 5t to the fourth plus 3. And that is the second derivative. It's okay? First derivative.
So it's tangent of
No,
sine
it's
theta of the
cosine
whole thing,
sine first.
right?
Yes.
Take out sine first.
Nope. Sine is in the angle of the
So it's the
tangent.
whole thing squared right now.
Right. This is really tangent of sine of theta at the angle, and then square the whole thing. Right.
So it's 2 times tangent of sine theta times
Like, why do you put the 2 in the side inside? What's the point of that?
Hmm?
Why do you write it? Why is it written like that sometimes? What's the point?
Like what?
So there's 2 next to the tangent, then on the side.
Oh, this is just notation for that. Right. If you put the square at the end, it means you're squaring the angle. If you put it on the tangent, it means you're squaring the whole thing. It's just notation.
times secant of sine theta times cosine.
Right. You have to differentiate the tangent, which the outside function is secant squared of, and you leave the inside intact.
Still in my right thoughts.
Then multiply by the derivative of sine. So this is 2 cosine theta and sine theta. Secant squared.
So is it okay to just leave it over there, like the last step? Because you don't need to change anything.
Okay.
Is it okay if you leave your answer as the first one?
No.
You didn't change anything, you just brought the cosine.
Yeah, I rewrote it. But notice that here, this guy would cancel with one of those.
Oh.
Right?
Wait, what?
Oh, that's a theta. It's not a secant theta. Nah, thought we were getting. Because secant is 1 over cosine. So I was hoping we would cancel it.
So if it was
No, the
secant
angle here.
theta.
If this was a theta, we could have done that, but it's not. Yeah, it's a makeshift rule.
Is that like 3 times the multiplication thing?
Right. Yeah, we'll just do it and not simplify. So you remember how to do the one with triple, right? You notice you have 3 functions being multiplied here. Basically, the product rule says each guy gets to be the derivative 1, so you add them all together. So in the first case, you differentiate this, leave the other 2, plus differentiate this, leave the other 2, plus differentiate this, leave the other 2. So here, cosine is minus sine, leave the other 2.
Wait, why is the 2, like, why does nothing happen to the 2?
2 is a constant. Right? The constant just stays.
I thought constant goes to 0.
That's if it was separate. It's not. It's being multiplied.
Wait, are you doing product rule? Wait, how do you do product rule with 3 things? H, right? H.
Every time you.
It's like F1GH, then F.
Yeah, it's like f, g, h. If you want the derivative of that, it's f prime g, h plus f, g prime, h plus f, g, h prime. Everyone gets to be a derivative 1 time. So in this case, I differentiate him, leave the other 2, plus, I'm going to leave the first one, differentiate this one, just secant squared sine theta times cosine theta times, leave this one alone, secant squared sine theta plus, now I differentiate this guy, leave the other two alone, 2 cosine theta tangent sine theta.
Wait, hold on. Isn't it 2 secant? Something?
2 secant sine theta times the derivative of secant is secant tangent.
Wait, so when you're differentiating that thing, you first take out the 2? And
Yes,
then,
the 2 is like the outer 2. Bring it down in front.
and
Leave
then
this
you
alone.
rewrite this. Okay.
So you just leave that alone. Then you have to differentiate this guy. So derivative of secant is secant times tangent. The angle stays the same, but then at the last you differentiate the angle.
The first part is only for cosine?
Yes, I differentiated the cosine part here, I differentiated the tangent part here, and the last one I differentiated the secant squared. We won't bother simplifying.
Do you have
Hopefully
to?
you get the idea.
We won't
No,
get
but
something
you
as crazy
have
as
to
this.
simplify further. The problem with that would require simplifying.
No,
You don't have to simplify?
not that one.
Wait, that one won't show up on the final, or on the final you don't have to simplify?
Just don't worry about
Is
it.
that a valid answer?
No. I just don't feel like simplifying.
But you have to on the final. I'm not telling you.
Yes, in general.
Okay.
Yes, in general you should simplify. If you're not sure, you can ask me. Problem 3. Definition of derivative. So here my y is equal to 3 plus 2x minus x squared. And my x minus 1. Okay, so this always comes up in the compulsory section, so I put a couple examples here. I want to find the derivative y prime using the definition. So, what's that? So you remember the formula from always have x because of that.
Limit is h approaches 0 of f of x plus h minus f of x over h.
Yes. So this limit as h approaches 0 of, I go here, and everywhere I see x, I put x plus h. Minus, open brackets, with the f of x. Brackets important here. Parentheses, whatever. So now, start to expand and simplify. So this is 3 plus 2x plus 2h minus x squared minus 2xh minus h squared minus 3 minus 2x plus x squared. Notice that I keep writing the limit because I'm not taking the limit yet. I have to keep writing it. So 3 is the 3, 2x kills 2x, x squared kills x squared. And I'm left with this, and that. So this is just h times 2 minus 2x minus h over h. You cancel the h. And then you take the limit as h goes to 0 now, you would end up with 2 minus 2x. Which if you take the derivative the short way, you realize that's what the answer is, right? You'll double check with the power rule. So, no. Okay, that's the right answer. How do you find the tangent line when x equals 1?
Again, x.
Okay, one. Just put it in
Yes, but where do we plug it in first?
The
No?
original function?
If you plug in 1 in the original function, what do we get? 3 plus 2 minus 1, right? That's 4. What is this? This is like your y value for the coordinate, right? You know your x1 equals 1. Your n is equal to what?
When you put it into derivative.
The derivative evaluated at 1,
Okay.
which is going to be 2 minus 2 times 1, which is 0. So we know it's y minus y1 equals n x minus x1. But your n is 0, so you just have y minus 4 equals 0, or y equals 4. It's a horizontal tangent.
Wait, what would be a function that you would have a horizontal tangent line?
Any function can have horizontal. Well, this one you know
Oh,
is a
never
parabola.
mind. Wait, could you have a vertical one for any function? Could you have a vertical horizontal?
Yes, you can have a vertical tangent.
Can you draw one? Can you draw a function that has a vertical tangent line?
Yes, but not right now. There are functions with like weird inflection points where for a second it's like pretty much you have vertical tangent lines if the function is defined but the derivative goes to infinity.
Wait, so you said that's the horizontal asymptote? Or that's the horizontal line, tangent line? Yeah.
This is horizontal tangent line, not an asymptote.
Will that,
Polynomials don't have
will
asymptotes.
that be needed?
Huh?
Do you have to like specify? Okay. So y equals 4 is horizontal, x equals 4 is vertical.
Yes.
And then
But
like,
I'm finding the tangent line here.
okay.
Okay, that's the equation of the tangent. So that was a nice one. This one is not so nice. So this is the kind of problem you should be prepared for. And you have fractions, and to make common denominators and things like that. So again, we know that f prime of x is equal to the limit of h approaches 0. Three x plus h over 1 minus 2 x plus h minus 3x over 1 minus 2x over h.
It's not that bad.
Nope. So the LCD here is just the product of these two. So I can multiply by 1 minus 2x plus h times 1 minus 2x. Do that on the top and bottom. Because this guy here is the LCD of all the fractions.
Oh.
So I multiply this by that. In the first case, this cancels, and so you just have 3x plus h times that. Minus, in the second case, this would cancel, and you'd have 3x times over h times all of this. Okay, how do we simplify that? You just have 3, right? You just multiply out, right? So this is just x minus 2x squared plus h minus 2xh.
It's exposition.
Take the x, multiply this, the
You're
1.
not doing 3?
Yes. I'm just doing the bracket part. I'm going to do the 3 now.
Oh.
So I know it's 3x minus 6x squared plus 3h minus 6xh. Minus, now I expand this, minus 3x, minus 3x times minus 2x plus 6x squared minus 3x times minus 2h plus 6xh. This cancels that. This cancels that. This cancels that. So there's a 3h. Which cancels. And so finally the answer is 3 over 1 minus 2x all squared. And because that was a long and arduous process, I probably checked my work. If I did it with the quotient rule, hopefully that's what I'll get. 3x over 1 minus 2x. Then y prime would be the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So this would be 3 minus 6x plus 6x over 1 minus 2x all squared. These guys dividing just have 3 over 1 minus 2x all squared. We write x, y to the fourth plus x squared y equals x plus 3y. So I want to find dy dx. And tangent. And
Just don't you just tangent into that?
did we have to?
What is it?
Oh, yes. Tangent line at x equals 1.
Maybe it's-
You're not gonna do it because there's a lot of
Okay.
Yeah. Right?
Yeah.
Right, so you plug in 1 into this to get the slope, to get the n. And plug in 1 into this to get the y value. So it's y minus this equals n times x minus 1. Maybe erase the problem. How do you find dy dx?
That's derivative, right?
Mhm.
So what's the difference between dy dx and d over dx? This is in terms of what? What does that mean?
dy dx means take the derivative of y with respect to x. d dx is something you put in front of a function to find the derivatives.
So
Like
there's
dy
no y.
dx, it means d dx of y, right? Whatever. Right, so this by itself is incomplete, it doesn't mean anything. You have to put it, find the third, use it to attach to something.
So they can't say find dx. Okay.
So just by saying dy dx, that tells you that x is the independent variable. So every time you differentiate the y function, you have to attach dy dx. When you differentiate an x function, you do have to do it. So here,
Y to the fourth plus x.
to the fourth plus x times
4x and y cubed dy dx
dy dx
plus 2xy plus x squared dy dx.
dy dx.
1 plus 3 dy dx.
Right. And now I want to solve for this guy.
You're gonna bring them on the same side.
So put everyone on the same side. So here I have
4x
4xy cubed plus x squared minus 3. All of that is times dy dx. Bring them all over here. Then this guy move over there. Minus y to the fourth
2xy
minus 2xy plus 1.
plus 2 minus 1.
No, because one's already over.
No, 1 was already over. The equals.
Oh, you're going to that, okay.
So I move everyone without him to that side, move all the y primes to this side. So that will be your y prime.
You don't have to simplify. You can't
No.
simplify.
Tangent line. Well, first we can find our m. This just means you plug in that number into here for x. Right? So this becomes minus 1 minus 2 radical 3 plus 1 over 4 radical 3 plus 3 minus 3. Right? So that's gone, that's gone. Radicals 3 is gone, so this is actually just minus a half. Right? So this means the tangent is y minus y1 equals m x minus x1.
You wouldn't want us to simplify that?
Simplify how?
Like multiply 1/2 by that and then bring.
I don't. As long as it doesn't say put it in a certain form, I just leave it wherever. You remember how to find absolute max and min?
Or you find the critical point and then check for the critical point and the endpoints.
So this says find absolute max. All right, find the derivative first because you have to find the critical points. So for critical points, you know that this guy's is equal to 0, right? Derivative is 0 or undefined, but it's a polynomial, it's never undefined, so it's just said equal to 0, and now I want to solve for x. I can divide 3 by 3.
If it was undefined at a certain point, you just.
You have to test that point.
Okay.
So, does this factor hopefully? Minus minus. So your x is either 3 or your x is 1. Do we have to check any of these? You don't have to check one. You have to check one. Only check x equals 3, right? Because x equals 1 is not in the given interval, 2 to 4. Right? So we only care about f of 3. We also care about f of 2. We also care about f of 4. Right? So this is from testing, we have to test all the critical points in the interval, and we have to test the endpoints of the interval. So f of 3, this is just 3 cubed minus 6 times 3 squared plus 9 times 3 plus 1. Okay, so this is 3 cubed minus 2, 3 cubed plus 3 cubed plus 1. So that's just 1. Plug in 2. 2 cubed minus 6 times 2 squared plus.
Hold on, I don't know.
Huh?
Would you be able to say? Okay.
Well, 6 is 2 times 3.
Oh.
So then I can take that 3, multiply this to get a 3 cubed. And 9 is already 3 squared, so that's again a 3 cubed. And so I can just work with 3 cubes. So this would be, I can't really work with 2 cubes here. So this is just 8 minus 24 plus 18 plus 1.
3 and 1 are critical values.
Yes, but only 3 is in the interval, so I ignore 1.
So about the critical, like if it would ask for critical value, it would only put in
Yes, 1 and 3.
1 and
Okay.
3, you just said
1 and 3 are the critical points of this function.
okay.
But we only care about this interval. 1 is not inside it, so I ignore it. So now we have to do this guy. 18 plus 8 gives us 26 minus 24. That's 2 plus 1, that's 3. This is going to be annoying. 4 cubed minus 6 times
To show you work with that?
4 squared. Well, you have to get to the end values here, yes.
Okay.
Plus 9 times 4 plus 1. What's 4 cubed?
4 cubed is 64.
Minus, what's 6 times 4 squared?
64.
No, that's 16. Wait, 6 times 4 squared is 16 times 6 squared.
96.
Yeah,
96 plus 9 times 4,
36.
36 plus 1.
Are you waiting for us or are you like?
Yes, so what is this? 96 minus 36 gives me what?
50, 40. 70. What was it?
Minus
60,
60.
60, 60.
Minus 60 plus 64,
32.
so you get just
4.
4 plus 1, you get 5. Yeah, the arithmetic is what's going to kill us.
Oh my god.
This is why you have calculated.
Okay, so now how do we answer the question? Say the absolute max is
F of 4 equals 5.
f of 4 equals 5. Absolute min is f of 3 equals 1.
What if two of them have the same value?
Then you just say it's equal to f of 3 equals f of whatever else.
Okay.
So you find all the critical points that are in the interval. You test out the value of the function at those points and the value of the function at the end points. And whoever is the biggest is the absolute max, whoever is the smallest is the absolute min.
Can the endpoints not be a critical point?
Yes, it doesn't matter what the end points are. You just test them, whatever they are. One. Integrals. Someone said they had trouble with these.
Wait, why is the absolute That's the lowest value in the end.
The lowest value. Right.
So f of 2 would be an absolute
F
value.
of 2 is, as far as absolute extreme is concerned, it's nothing.
Oh, relative. Relative is called?
F of 2 would not be a relative either, because it's not a critical point. 2 is not a critical point. So it's neither a relative extreme nor an absolute extreme.
So where would it be included?
Just nothing.
It's just a point.
It's not really interesting.
So that's what absolute extreme is, the max and min. That's all they're
The
looking
biggest y value and the smallest y
We're just
value.
looking for 2 values.
Yeah. They may or may not be critical points.
What if there are 2 y values are the highest?
She just asked that.
Who?
Like say, yeah, like you get like f of 1 and you get that's 5, and then you take f of 3 is minus 1, and then you find f of 4 is also 5. Then you can say the absolute max is f of 1 is equal to f of 4 is equal to 5.
Okay.
Right? And absolute minimum would be.
That's a good question.
Could be.
Is it?
How do you do that?
Integrals are not my forte.
Why do they skip chapters? You're looking to end now.
Well, in a final, usually this is how it looks, right? They give you a bunch of derivatives, then a bunch of integrals, then they jump into other stuff.
So what do you want to explain? The what?
I need you to be able to switch your brain from derivatives to integrals at a moment's notice.
You write it as like x squared minus 1
I don't know how to do
squared times x to the negative 1/2.
Right, so basically remember with integrals, what do we know? We have these basic rules, right? We know how to anti-differentiate this. What's that?
Fx.
No. X to the n plus 1 divided by n plus 1 plus c, and this is if n is not minus 1. The case where n is minus 1, you do that in Calc
So
2.
you don't keep dx in anything?
No.
Okay.
And we know how to integrate sine x, right? What's that? Minus cosine x. We know how to integrate cosine
So
x.
it's antiderivative. So
Sine
integrals are
x.
asking for antiderivative.
Yes. These integral acts are antiderivative. We know how to integrate something like secant, right? What's that? Tangent.
Is it
Right,
negative?
you're just going, no, just kidding. Because the derivative of this is that. The derivative of this is that. The
Yeah.
derivative of this is that. What about secant tangent?
Cosecant.
No.
Cotangent.
No.
What's left?
Derivative of what
Cosecant
gives
squared.
secant tangent? You can't just guess, right? There's 6 options. The probability of you getting it right is like 1 over 6.
It's secant. Really?
Yes. Derivative of secant is secant tangent.
That's interesting.
Why?
What if I put cosecant squared? That you should also know.
Cotangent.
1/2 of
What?
Minus
that.
cotangent.
I don't know.
I was so
How do you do
close.
reverse
I said
table?
cotangent.
How do you do reverse table?
Wait, isn't there like an easy way to remember that? Like when we were in junior
Not that I
high
know,
school,
but-
like you know they had this table like how you would know negative times negative is positive and all that. So
What if it's
there's
cosine
no
squared?
easy thing. And like all students take calculus, there's nothing.
Not that I know.
You should really
If
make
you ever
one,
figure out, if
because
you ever
like,
find
it would be
it, tell me.
legendary if you do that.
I don't
You
know.
know, if you memorize these thingies in another language, they're so much easier. If you know another language.
That
It
has
makes
math
something-
like that?
No, just
I don't
make
know.
something up and like.
Only
I can't explain
America
it.
has done this.
Wait, how to get the integral cosine squared?
So,
Do we know that?
that one is hard. It's harder than you think. You have to write it using a trig identity. This is just a half times 1 plus cosine 2x.
Wait,
Yeah.
what?
No one's
1/2? What is 1/2?
Yes. It's a trig identity. Cosine squared is 1/2 1 plus cosine 2x. Sine squared is 1/2 1 minus cosine 2x. So you rewrite it as that, and then you can integrate this. This one you need substitution for, technically. With enough experience, you can do that kind of substitution in your head.
Oh, so we haven't learned how to do cosine 2x?
We know, you know how to do it. You're supposed to. We'll do it soon.
How?
Right, so the idea behind integrals is we have these basic rules that we know, right? And we're always looking to apply them. Anything else we get, we want to write it to look like one of these, basically, right?
Wait, I have a question. So
Yes.
when do you make it plus cx plus d? When does that happen?
Once there are no numbers on the integral, you put a plus c,
So when do you put plus d?
plus d.
You've done that before, plus cx plus d. No?
That's if you're doing it twice.
Oh. Okay.
Okay? So, I want to write this to look like one of those. Which one am I going to try to write it to look like? Well, obviously none of the trick ones.
Yeah.
Have to look like that, right? So,
X squared minus 1.
I'm going to start multiplying out. X to the fourth minus 2x squared minus plus 1 over x to the 1/2, right? Then what?
I don't know.
What is
So
oh, I got it.
Just bring
Oh, you didn't do anything yet.
X
No, I expanded this.
times
Why
X
didn't you
to
just
the
add
negative
1 to 2?
Yeah, I divide this into each term, right? So I get 3 separate terms.
when do you know it's use substitution? Do they tell you when it's use substitution?
No, they're not going to.
Are you following that thing right there? You're supposed to add 1 to n, now you have no n.
I can only add 1 to n if I add something like x to the n, but I don't.
That's
I have a fraction. I have a rational. I have a fraction.
So then you can't follow that.
I can't follow that rule yet, no. Because I'm not done. What I'm going to do, I have to keep simplifying. Right? I can do this now.
Can you bring them up and be like to the negative sometime?
I could just subtract the powers, it doesn't really matter.
Okay.
So I have 8 over 2 minus 1 over 2. Right, so that's just 7 over 2. Minus, here I have 4 over 2 minus 1 over 2. So that's just 3 over 2. Here I have plus x to the minus 1/2. And now what you realize, each of these guys look like that guy. So now I can apply the rule. So sometimes you can use algebraic manipulation to make it look like one of the basic rules. Sometimes you need substitution, right? And in Calc 1, that's all you have to worry about. Can I simplify to look like one of these guys, or do I have to use substitution? In this case, substitution would not work. When we get to substitution integral, I'll say why. But it wouldn't work here. And so now we just integrate these. So you just add 1 to the power divided by the new power. Right, 1 is 2 over 2.
You have to keep the x the whole time.
Or, you know, this is just multiply by this. Minus, here you add 1 to the power, divided by the new power. It's 2 plus add 1 to the power, divided by the new power. Problems like this are very typical on a final, where you have to. This is one of the kinds where you don't need substitution, but you need to simplify before doing the integral. They like to put those on. Moving along. E. 2x cubed times cube root 3 minus x to the fourth.
I'm sorry, what did you do? You define polarities now?
Anti-rule.
Okay.
Here's where I apply that rule, x to the n dx. Is I added 1 to the powers and then divided by the new power.
Divided by.
So if I add 1 to 7 over 2, I get 9 over 2. Dividing by 9 over 2 is the same as multiplying by 2 over 9. Flip the fraction.
Okay.
So So I'm just applying this rule to each term.
Oh, so, okay. So then you don't have to actually go through the whole anti-derivative thing, you can just follow that rule.
Yeah, this rule.
And it will always work.
Yes.
Okay.
It works on anything that looks like this, where this power is not minus 1.
Where it's not minus.
Where it's not minus 1. Yes.
Do you have a problem for that one?
No, if that's calc 2.
Oh, okay.
Well, for you, it's technically supposed to be recalc 1. If you did 205, you would have done that case. Okay.
Wait, but in 209 I need to know that?
Yes.
That's really bad.
Okay, how do we do this one? Again, it does look like a basic rule. We want to make it look like a basic rule. But simplifying this, how are you going to do that? Can we do it? So, well, what are we doing? Substitution. It's the only other thing we know. Right? So, what do we substitute?
3 minus x over 1.
Okay. So remember, there are two things that is the goal of a substitution. You want to substitute something that makes your function simpler, and the derivative must be somewhere else in the function, right? If constant factors don't matter, but the function part of the derivative should be somewhere else in the function. Notice here, there was nothing really you could do that would make that work. Right? If I made my u be something, the other thing wouldn't be around to switch out.
Yeah.
Like
If you
what?
had, if you did derivative of x squared dx. Never mind.
Right, we don't have x. Okay, so you figure out who your u is, and then you have to differentiate, right? Because you have to replace both this and that. So I realize the cube root of this guy is what's making it complicated, right? If this was just the cube root of x, I could actually just use this rule right away. I wouldn't need anything. So this,
Is that a definite or indefinite?
this is indefinite.
And the first one was definite.
No, we haven't done indefinite. Definites have numbers on them,
Oh, okay.
right? If this was the problem, that would actually not be so bad. This is just times x to the 1/3. I just add the powers into the power rule. What makes this complicated is this part. So then I'm like, well, if that was a single variable, that would be easy. So I make it a single variable, right? And then I have to hope that if I differentiate this, I can find the function part of the derivative somewhere else, right? And so now what we do is differentiate du is equal to this is minus 4x cubed dx. And now I see that the function part, the x cubed dx, is actually somewhere else in my function as a factor. I have the x cubed dx there. So this means I can take out minus 1/4 du is equal to that x cubed dx. And then I go and replace all this in my integral. So minus 1/4 du replaces the x squared dx, x cubed dx. I'm left with a 2. And then this guy here is u. So this is just the cube root of u. Can simplify a little bit. The 2 can cancel to the 4. This is just minus 1/2 times. How can I rewrite this? This is u to the 1/3.
So you can technically take out the 2.
Yeah, constants we can factor outside integrals. And now that looks like this rule.
What form are you using? Is there a form to like remember?
This one.
That's the same thing?
It's the same thing.
Okay.
All right, remember we said the x is a dummy variable. If I write any other variable here, it's the same thing. So having a u here is the same. So I'm just going to add 1 to the power divided by the new power. So right, this is, it's more than just a rule, it's a form that you have to look for, right? If you have a single variable to a constant power, you can, this is how you would integrate it. So, this would be, you add 1 to the power, which is 3 over 3, this would be 4 over 3, divide by the new power, which is 3 over 4, this minus 1/2 is still there. This is minus 3 over 8. Now we replace the u. the original thing. What's that? And again, you can always check your answer. If you differentiate this, if you differentiate this, you should get the original function, 2x cubed times the cube root of 3 minus x equals. So you can always check your answer here. Once you anti-differentiate something, when you take derivative what your answer is, you should get the original function back. That's what the fundamental theorem of calculus is. That's what the fundamental theorem of calculus was talking about. C. This is a nasty one. I'll just. If you see something like this, it's a trick question. That's because we can't simplify it to look like one of those rules, and no substitution will work here. The trick with this is note sin x over 1 plus x squared is an odd function. Because if I let f of x equal this, then f of minus x would actually be the negative of f of x. Right? Because f of minus x would be equal to sine of minus x over 1 plus minus x squared. Sine of minus x, sine is odd, so that x is actually outside.
But if it was cosine minus x, would that still be?
If it was cosine x, it would be an even function and you'd be in trouble. You wouldn't be able to do it.
So cosine of a negative angle is always a positive number?
Cosine of minus x is the same as cosine x.
But sine of minus x is negative.
Sine of minus x is the negative of sine x.
What about tangent?
Tangent is also odd. Tangent of minus x is minus tangent x.
It's an odd function because of the integral.
Because of the sign. Yes, but we know that, what I told you, the integral of minus a to a of f of x dx is equal to 0 if f is odd. So this is just 0. You wouldn't have to show any work for it.
Was the question
Just
on
put
the
zero.
also zero? Was the question on the test also zero? There was a question like this on the test.
Like this? I put a plus minus on this? I don't think so.
Wait, why is it 0?
Because it's an
from
odd
1 to negative
function.
1? Or
Yes.
because of the sign?
Yes, because it's from 1 to negative 1, and this is an odd function.
So if it was an even function from 1 to negative 1, it wouldn't be 0.
No.
So you have to explain that, just put 0.
Yes.
You sure?
Yes. You can say put 0 and write because this is an odd
Because
function.
that seems very like, I could have just put 0 if I don't know what the answer is and I can write like,
Why would you guess 0 to that?
because it, I don't know, if it looks like that, then I'll put 0.
So if we
Between negative 1 and 1 is 0, that's how I got 0.
we
Or something, I don't know.
We haven't learned
No.
this case about even functions. So if we see something like this, we just put zero.
Because
from
if the
one to
function is
negative
odd, for even functions, that's not true. It's not 0 if it's even.
But if it was even, we don't know how to solve it, so they wouldn't give it to us.
Not this particular function.
If it goes from 1 to negative 1.
Something like from 1 to negative 1 of x squared is not 0 because x squared is an even function. You could actually find the answer to that.
Wait, should you try that with everything first? Or only like when they have, for like something?
I would look for this if, one, I realize I can't simplify this look like a base rule. Substitution doesn't work. Then I try to think of this because I messed up.
I mean, would substitution ever work for trig functions?
Yes.
Oh, if you have like a sine and then x.
Yeah.
If it was
In
an
fact, E
even
and
function.
F is substitution problems.
If it was an even function, that wouldn't, you would have to like, well,
The thing with even functions is it would just be the double of half the integral. having to do it.
Okay.
You can get out of it.
If it's neither, then.
If it's neither, then you have to just work it out.
I remember the lot even thing that was so long ago.
Alright, what about this one? X plus 2 over the radical of x squared plus 4x.
You can substitute x squared plus 4x.
Yes, equals x squared plus 4x. The du would be 2x plus 4x. Do I have a 2x plus 4 anywhere?
Yeah, x plus 2 means
And x plus
factor out
2. So how do I get that?
Factor out 2.
I can factor out a 2, and then I have that x plus 2 dx, which I have here. So I'm going to divide by 2. 1/2 du is equal to that x plus 2 dx. And so I can rewrite this into 1/2 du gets rid of this, and I'm just left with 1 over radical u.
How do you recognize it was a substitution?
What else could it be? I can't simplify this to get x to the n form. Right? I have a radical in the denominator. I can't split radicals across sums, and even doing that wouldn't help. Like, there was no way to simplify this to look like x to the n.
Why wouldn't that become a 0? Like if you are you dividing x plus 2?
No, this is 1 over the radical of x squared plus 4x times. Right? This wouldn't be a 0. If the top was a 0, the whole thing would be 0. It's just, you think of it as a 1. And so, this is just 1/2. How do I integrate this? Right, I rewrite u to the minus 1/2. And that looks like x to the n. So you add 1 to the power, divide by the new power. So that's just u to the 1/2 plus c. Okay, so E is what we call a definite integral. That's the one where they put the numbers on the thing. And we use the fundamental theorem of calculus to evaluate those after we find the antiderivative. So,
You can substitute tangent. Wait, is the derivative tangent secant?
nope, derivative of tangent is secant squared, so tangent would be a bad substitution.
What's the derivative of secant?
Derivative of secant is secant tangent.
That doesn't solve it either.
Yeah, because then this whole thing would just be du. Which technically you could do, but the substitution they would look for here would be u equals 2 theta. Why? Right? Because I told you down here there was a general rule. Secant x tangent x dx was equal to what? Secant x plus c, right? We had that rule. So this looks almost like that. The difference is they doubled the angle, which messed it up. So I'm saying if this was just an x, that would be cool. So I just made it a single variable. So yes, so du would just be 2d
Wait,
theta.
hold on. But x is just an angle. It's arbitrary. So why can't you just say the answer to that is just secant of 2 theta?
Because it's not. Because you have to remember the chain rule, right? If you have sine x and you wanted to differentiate it, it's completely different if you wanted to differentiate sine of 2x, right?
But x could be anything.
X could be anything, but 2x is not going to be the same as x.
But that doesn't say secant of 2x. It says secant of 2 theta. It doesn't really
secant of 2 theta and secant of theta behave very differently. They're actually two different functions.
Okay.
Right? Your sine of x would look like this, and your sine of 2x would look like this. Right? So this one is a lot more crazy than that one. It moves twice as fast. So the derivatives here would behave very differently, and so would the integrals. Right? So don't think of it, oh, it's just a 2, that shouldn't make a difference. It makes a lot of difference. Okay? Right? The idea is once it's not just x, you need like a substitution or something to deal with. So here is 1/2 du, gives me that d theta, and so I can actually rewrite this as 1/2 times secant of u tangent of u du. Right? So it's very important you know these basic forms. You're always trying to look for that form. Right? And it has to be exactly, right? If you have an x, it has to be just a single variable. If you have a constant multiplication, you can't just follow the rule. You have to do substitution.
So what did you replace? You replaced d theta?
Yes. I replaced these with u's, so I need to figure out what's this.
So
Right?
that becomes 2u.
No, it becomes half.
Can you use something other than u? Like if it was 2 theta and 4 theta?
If it was 2 theta and 4 theta, you couldn't do it. Not with Calc 1 anyway.
Okay.
So the integral of this is just 1/2 secant u. Well, not plus c. So remember here we had theta going from 0 to pi over 8. So this is theta goes from 0 to pi over 8. So this is secant of 2 theta from 0 to pi over 8. So how do we do with this guy? How do we evaluate this?
Why are you guys so quiet? Nobody knows what to do?
Just make you want to know like exactly
What's secant of
2
0?
times pi over 8.
Yeah, you plug this in for the variable, right? You plug in the top one, and you get secant of pi over 4 minus, you take the same guy, and you plug in the bottom number, right? This was the fundamental theorem calculus. Take the top number, plug it in, minus, take the bottom number, plug it in, and then you evaluate it. Secant of pi over 4 is what? It's radical 2.
Wait, you left so much out of it.
What? Secant of 0 is 1. So
You're supposed to have half integral secant of 2 theta tangent 2 theta du, and then du would be switched. Du wouldn't be switched. Oh,
I switched everything from theta to u's. There should be no thetas left over.
du becomes c. Wait, what did you just say?
I'm changing the variable. I'm changing everyone to u's. U is 2 theta.
Okay,
And then I found that d theta is a half du.
okay.
So then I put a half du. That replaces d theta, and these two are u's.
Okay. So then you're supposed to
Then
replace
that looks like a basic rule. That's just secant. Right? The antiderivative of secant tangent is secant.
Okay.
And now remember I have these numbers here, so I have to take the top one, plug it in, minus the bottom one, plug it in. That's the fundamental theorem. And then you evaluate that. Secant of pi over 4 is radical 2. Because secant is 1 over cosine, cosine of pi over 4 is 1 over radical 2, so you just flip it, you get this. Secant of 0 is 1 over cosine of 0, which is 1. Cosine of 0 is 1, so this is just
Is it okay if you just left it at that so we do 2 minutes on
oh, that's fine.
Will it say if it's fundamental theorem calculus?
Nope.
Okay.
They'll ask a question like that. Do this integral.
can do it however you want.
Yeah. So remember we showed you how to change the limits. Do you guys change the limits or you just leave it open? You just leave it. All right. So after you find what the answer, just plug in back the u and then just use the old limits. You don't have to worry about changing limits. In Calc 2, you worry about that, especially when you're doing trig substitutions.
So this is a definite interval, which means you have to use, so if it was indefinite, then the answer would be half secant 2 theta.
1/2 secant 2 theta, yes. This is cosine x over sine to the 4th x. How do you do that one?
You use sine squared x? I don't know what it is. The one that had the cosine. But square it.
I'm not sure what you mean.
Wait, what's that formula that sine squared x equals something cosine?
You don't need that. You think it's too complicated.
You have to use equal to sine x.
U is equal to sine x. So du would be cosine x. Right? Which I have. So this becomes 3 over u to the 4th.
U is always either the bottom, the denominator, or the bracket.
U is usually whatever makes the thing more complicated and its derivative is somewhere else. So here, if it was 3 cosine, that's easy. The fact that there's a sine to the 4th in the bottom makes it complicated. So I want to get rid of that sine to the 4th, so I just replace sine with a single variable, u to the 4th. The derivative of sine is cosine, which is there, so that's just my integral. And how do I do this one? It's just 3u to the minus 4. So this looks like an x to the n. You add 1 to the power, divide by the new power. Let's see. So this is just minus sine x to the minus 3 plus c.
How'd you get negative and the bottom?
You add 1 to the power, divide by the new power. Remember? It's x to the n plus 1. You put the n plus 1 on the bottom as well.
Oh.
Switching gears again. What kind of problem is this one? Related rates. 7. The radius of a sphere is increasing at a rate of 4 millimeters per second. How fast is the volume increasing when the diameter is 80? So it's asking for a rate, how fast something is increasing. So how do we do it? So usually remember the steps to doing related rates was what? You read it, you draw a picture if possible, right? I mean, drawing a sphere here wouldn't really help us much, there's no point. You label the diagram properly, you find an equation that relates all the variables. Well, we know the equations for area and volume. Differentiate implicitly with respect to time, and plug in what you know, solve for what you don't know. What do we know here?
Wait, so what are the geometry formulas that we have to memorize? But you give this to us. Would you give it, would they give this to us on final?
They might.
Big ones.
Oh. Sphere? That's so bad. Like,
What about like cones?
They might. They'll give you the ones that are not obvious, don't worry. Okay.
Wait,
what
they'll
do we
give you the
know
ones
here?
that are not obvious?
Right.
Oh, they'll give it to us. I'll give it to you.
Like it's a rectangle, they're not going to tell you it's like that
Oh,
too, but it's like a cone. Who remembers a cone?
Right.
You know? Okay, what do we know here?
that's a sphere.
The radius, right? We know dr dt. We know how the radius is changing. It's changing at a rate of 4. Positive because it's increasing, right? Now, that's the only thing we know. What do we want? How fast is the volume increasing? So we want dV dt when what happens? When the diameter is 80, which means my radius is actually 40. Right? So since I want dV dt and I know about dr dt, I'm going to want an equation that relates V and R, which is the volume equation. That's the equation for the volume of a sphere. Differentiate implicitly with respect to time. So this would be 4 pi r squared. When this 3 comes down, it cancels. I want to find dV dt, so that's already over here. I want to know, talking what I know. So I know that R is 40. I know that dr dt is 4. So dV dt is 60 times 40 squared.
They gave you the area and volume formulas.
Yeah, like here we didn't need the area formula.
But it's given anyway, so you can figure it out.
Well, it's given because of the next problem. What rate is the area of the above sphere increasing? Right, so it's the same sphere, but now we want to use area. We know that the area is what?
4 pi r squared.
So here is 4 pi r squared, and this means dA dt is 8 pi r dr dt. This means dA dt is equal to 8 pi times 40 times 4. Right? So this is 8 times 165. Do you know 8 times 16?
128. Calculator.
I mean, you could.
9. It's another related rates problem, right?
Why are you going through them so quickly? How does that would have taken me forever.
Because he's obviously master.
We're going there quickly because we have tons of problems to do. I want to make sure you can attack all the sections on the final. So get through a lot of stuff.
Thank you.
Yes,
Okay.
thank you.
So 20-foot ladder, how do we set this up? So this one you can go through the steps, like all the steps, right? So read the problem carefully. We draw a diagram to represent the situation, which in this case is a right triangle. Right? So a 20-foot ladder leans against a vertical wall. The foot of the ladder is being pulled away from the
There's
wall.
no shadows on the final, right?
Oh God, please no.
Or any shadow problems?
You know that question that made me cry on the test?
Is there a final shadow thing?
Oh
The
my
shadow?
God, don't remember. And mental breakdown.
Like, why is he walking out there at night in the first place? It's horrible. Come on.
Wait, are there zero problems? You never answered the question.
Huh? I don't think so. Okay, so 20-foot ladders against the wall. The foot of the ladder is being pulled away at 5 meters per second. How fast is the top of the ladder sliding down the wall when the foot is 12 feet away? So we label the diagram and we're careful. We label things that don't change by constants, like the length of the ladder is a constant. Things that change we label by variables. So the distance from the wall is changing, and so is the height on the wall changing. So I label those with variables. Next, we write down what we know and what we want. Right? That's related rates.
dx dt is 5.
We know dx dt is 5 because it's increasing, right? So it's a positive number.
We want dy dt.
Right. We want to know what is dy dt when what?
When the ladder is 20, we know.
The ladder is always 20.
Oh, when the ladder is 12 feet. Oh, when x is 12.
Right. So now you have to set up an equation that relates both of them, right? What's the equation?
A squared, b squared equals c squared.
Right, Pythagoras' theorem. X squared plus y squared equals 20 squared. Differentiate implicitly with respect to time. 2x dx dt plus 2y dy dt equals 0.
Will the final have something more complicated than this? Like, remember when there was like the rectangle within a rectangle and things like that?
Don't worry. Between this review and the mock exam, you should be prepared for what the finals will be. Okay, so now we can plug in what we know and what do we and solve for what we want. So we have 2x, we know is 12, dx dt, we know is 5, plus 2, what's y?
Y is given?
Do the 12.
Y is 16. How do you know it's 16?
12, 26.
Right. So remember when I gave you that handout, there was a clause that says sometimes you're going to have to go back to your original equation to figure out some stuff. So they told us x, I can just use this equation to solve for y. But I can see pretty quickly, hopefully, that this triangle is a 3, 4, 5 triangle. Right?
Oh.
This is 5 times 4. This is 3 times 4. So the other side must be 4 times 4, right? It must be 3, 4, 5. So this means that your y is 16.
Can you quickly write down the special triangle thingies?
So what's Y?
And how many of them are there?
So I have to plug this in.
Oh, and you don't know what's Y and Z is, okay.
Right, dy dt is what I want to find. So now I can find it. So dy dt would be, take this guy and move it over, I get minus 2 times 12 times 5, divided by this one, 2 times 16. 2's cancel. 2 into 16 goes 8. Or I can take 4. 4 into 16 goes 4. 4 into 8 goes 3. Minus 15. And you can put that in units if you want. I don't really care about units. It's not physics class.
So you don't need measurements.
Right. And it's supposed to be negative because the y is decreasing. Right? It's getting small.
So how do you tell these apart from optimization problems?
Because they'll ask you for a rate.
Oh.
Right? how fast is this moving? How fast is this increasing? How fast is this decreasing? What's the rate of this? That's the related rates. Optimization, they're going to ask you to maximize or minimize something. You know, how do you make this as large as possible? How do you make this as small as possible? Right? Those are optimization problems. Once they ask you for a rate, a speed, you know it's related rates. So, we're about halfway done. Do you guys want to take a break or do you want to keep going?
Wait, do you have time to take a break? I think we should keep going, but you know.
Okay, keep going. Curve sketching. So yeah, again, they'll give you the derivatives, so you don't have to worry about finding them. So that's the nice thing. So you just need to know what to do with the information when you have it all on hand. So
on the final, it'll tell you.
they'll tell you specifically what they want.
Okay. I understand.
Yeah, I just couldn't bother. I just made this right before I came here. So my function is x squared over x squared minus 4. I'm given that the derivatives are minus the x over x squared minus 4 squared. The second derivative that was a square. Okay. It's supposed to be a square root. We will see. Alright, so the relevant features I'm talking about, they're going to ask you for like intercepts, asymptotes, interval of increasing, decreasing, intervals of concavity, where are the inflection points. Those are the guys I'm talking about. They'll specifically ask you for these things, the max and mins. Right? So usually first thing they want to define is the domain. What's the domain?
That's the number.
Right. Minus 2 or 2 will make the denominator 0, so you have to skip those. Minus 2, minus 2, 2, 2, and you have to skip minus 2 and 2. By the way, on the test, some people miss the middle interval. You have to be careful. Only the minus 2 and the 2 should be. Okay, what if they ask you for the intercepts? How do you find the x-intercept? Here you set y equals 0 and solve for x. This means x equals 0. It's the x-intercept. The y-intercept, you set x equals 0 and solve for y. So again, that's y equals 0. So it only intersects the origin.
Why is y 0? Before. Oh.
You plug in x equals 0 and you evaluate the y value.
But that means it'll always be 0.
Yes.
Y-intercept and x-intercept are always 0?
No. For this particular thing, they are 0.
Okay. Oh, so if it was like x squared plus 1, it would be
Yeah, it wouldn't be 0. In fact, if I put an x squared plus 1 here, there would be no x-intercepts. There's none at all. So what else do they ask for? Asymptotes? Let's find the vertical asymptotes. Remember, this would be where the denominator is 0. So x equals 2, x equals minus 2 are the vertical asymptotes. What are the horizontal asymptotes? How do you find those? Right, find the limit as x approaches infinity of the function and the limit as x approaches minus infinity of the function. What's the answer for this one? both cases. Why? So ratio of polynomials, and we know how those behave when the powers are the same. It just goes for the ratios of the coefficients, right? When you're taking the infinite limits of the ratio of two polynomials of a rational function, the highest powers are the same, it goes through the ratio of the coefficients, so it just goes to 1 over 1.
Wait, are there going to be limit problems on time?
Yes, there are limit problems on time. There are limit problems on every time. Yeah, they're going to have a problem where they say, find all these limits. Okay, so the horizontal asymptote is y equals 1.
So how do you know there is no horizontal asymptote? If it goes to infinity, there's no.
If it's not a constant, then there is no. But once there is a constant for either one, that's a horizontal asymptote.
And if it's 0, it's also horizontal.
0 is a horizontal asymptote, yes. Okay, the next thing they'll want is what are the intervals of increasing or decreasing, what are the maximums or minimums. How do we find those guys?
Find derivative.
Use the first derivative.
Equal to 0.
Right, equal to 0 and undefined, right? So where's the derivative 0? So here, the test points would be what? 0 or plus or minus 2, right? It's 0 when x is 0. It's undefined when x is plus or minus 2. Right? So you set both the numerator and denominator to 0 and solve for those x values. And you're going to test them in the first derivative. So you have 0, or minus 2, or plus 2, and you're going to plug in a number in between each of these. So like minus 3 you can plug in, minus 1, plus 1, 3. Plug it into the derivative. Notice that the denominator is a square, so it's always positive. So you only look at the top, right? If I plug in a minus 3 in the top, it's positive. That means increasing. If I plug in a minus 1 in the top, it's positive. So it's still increasing. If I plug in a positive 1 in the top, it's negative. Decreasing. Plug in a positive 3 in the top, it's still negative. So it's still decreasing. So this is nothing, right? Especially because it's undefined here. Technically, the derivative doesn't even exist at 2 or minus 2. What about 0? It's a maximum, right? This means 0, 0 is a maximum. It's a relative maximum. Where is it increasing? Minus infinity to minus 2, union minus 2 to 0. Or is it decreasing?
Wait, so if you write negative infinity to 0, that's wrong.
Technically, yes, because minus 2 is a bad point. You always skip over the bad points. It's decreasing from 0 to 2, union 2 to infinity. So here we've identified the maximums. There are no minimums. And these are the intervals of increasing and decreasing.
0 is relative and absolute max.
We never said it's absolute max. In fact, we know it's definitely not the absolute max. That function actually gets bigger than 0.
So there will be no absolute extreme.
Not for this one, no.
Wait, so when you're graphing it, you're never going to have inputs?
Well, after we find out everything, we'll worry about what it looks like. The next thing they'll ask you for is concavity and inflection points. Right? So they always say, find the domain and the intercepts of this. Find all the asymptotes. Find where it's increasing, decreasing. Find the maximums and minimums. Find the intervals of concavity and find the inflection points. So here is where you work with the second derivative. So you make this 0 and undefined. So what x's make the top 0? None, right? But the bottom is 0 plus or minus 2. So the only test points are plus or minus 2. So now we're going to test in the second derivative, because that's the one that tells us about concavity.
Wait, don't you set the second derivative equals to 0?
Yes.
Wait, why haven't you just zero?
0 is not a critical point. If I put
Oh,
in-
you set it
if
to
I put in
zero.
0 for x, it's not 0.
Don't you set it equal to 0 and solve for it?
Yes. So if 8 times 3x squared plus 4 equals 0, this means 3x squared plus 4 equals 0. This means x squared would be minus 43, which is never true. It's never 0. This is never 0. Right? So where it's 0, there are no critical points. It's never 0, but it's undefined when plus or minus 2. So our only test points are plus or minus 2.
So for critical points, you type the bottom and the top separately.
Yeah, set the top equals 0, set the bottom equals 0. Find out about this, right? And that's what I did here. I said the top equals 0 and the bottom equals 0. Top was 0 and x was 0. The bottom was 0 and x was plus or minus 2. Test those. Do the same thing for this one. Top equals 0, bottom equals 0. And plus or minus 2 are the only values. So again, I can test here, minus 3, I can test 0, I can test 3. Again, hopefully this is the right power, I copied everything down right. So we're ready for it to be squares in both of them. And worried that that might be acute. We should probably double check. You don't want to go through all this and then it's wrong. Okay, so if we have minus 8x over x squared minus 4 squared, this is the bottom times the derivative of the top minus the top times the derivative of the bottom. Over this guy to the fourth. Right, so you cancel this and you get a 3 here.
Well, we get that much.
And then we have minus 8x squared plus 24 plus 2 is 4, 8 times 4 is what? 32. X squared. X squared minus 4 cubed. So 32 minus 8.
28. Is it before?
Is that 24?
Yeah. 8 plus 4 is 12.
Yeah, 24.
Did I do something else wrong? Here, I had minus 8 squared. This was 8 times 4. So this would be what, 32?
So then it won't be x squared, the last one will be just x. But that's another thing. Well, that is not x squared.
So it's the bottom times the derivative of the top minus the top times the derivative of the bottom.
You said minus, but it says plus.
Correct, because the top was minus.
Okay.
If I take minus the minus 8, I get plus 8.
Okay.
Right? This would give us 16x squared. 16 times 2 is 32.
Why did you add 8x and 8x?
So this is 24 squared plus 32. Yeah, I think it's a cube. And then you factor out, and then you can factor out 8. So 8 comes out here, you have 3x squared plus 4.
Yeah, that's all.
Why did you add 8x and 8x? It's multiplication.
I'm not
theta times theta. Oh, it's 2.
2, it's a 2. It's a 2. Yeah. So this is a typo. It should actually be a 3. Should probably write over on all these things. It's fine. Okay, so that's actually cubed. So now we double check. So the top is always positive, so now really I'm only watching the bottom. Right? So if I plug in a -3 in the bottom, it gives me a positive number. So positive, which means concave up, like a cup. If I plug in 0, it gives me a negative number, down like a frown.
Wait, so when you're checking those numbers, you check the top and bottom separately?
Yes. I want to figure out the sign. The sign of this thing. So I plug in -3 into the top, it'll always give me a positive number because the top is always positive. It's a 3x squared plus 4 times 8. That's always going to be positive. When I plug it into the bottom though, -3 gives me a positive number in the bottom. 0 would give me a negative number, 3 would give me a positive number. And the second derivative, positive means concave up, negative means concave down, which means these guys are what? They're not inflection
Can't
points.
use them because they're undefined.
Because it's undefined there. They would be inflection points if the function was even defined there, right? Inflection points, your second derivative has to be 0 at the point, and then switch signs. But it's not 0 at the point. It's undefined at the point. So they're not inflection points. So these no inflections.
Does it still change concavity?
But it does still change concavity. So I know it's concave up on -infinity to -2, union 2 to infinity, and I know it's concave down on -2 to 2. And with that, we can draw the graph. So we start by putting in our intercepts, which is just 1, it's the origin. Vertical asymptotes, it goes as broken lines.
So you can cross the horizontal ones, but not the vertical ones.
Yes, you can cross horizontals, but not necessarily verticals.
Not necessarily.
Not verticals. You might cross a horizontal, you might not, but it's possible. But it's not possible to cross vertical lines. Okay, so now those are intercepts, asymptotes. I have a horizontal asymptote as well at 1. Is that right? What else do I have? Okay, so now I'm going to start putting in these guys. I know the origin is a maximum point, so I can label that. I also know where we're increasing. Where are we increasing? From here all the way back, I'm increasing. I'm also increasing from here all the way towards there.
Wait.
Oh,
The
so next
Where?
-2 to
Oh, -2 to 0. Oh. I thought it was -2 to infinity.
No, there's something wrong.
No.
No, that's increasing. Okay. And everywhere else I'm decreasing, right? Decreasing here and decreasing here. So when I'm on this side, my graph is always going up. When I'm on this side, my graph is always going down. Now let's put in concavity. It's concave up on the outside. So over here, it's concave up. Here, concave up. And everywhere in the middle, it's concave down. Concave down.
That means you're going to have fragments at -2 and 2 to show increase and decrease.
So this is a maximum, so I know it looks like this, right? So that means that the middle would look like this, right? I'm increasing and I'm concave down. On this side, I start decreasing, I'm still concave down. So I shape like a frown the whole time. So this part just looks like a parabola. Now over here, I have to be increasing, right? Now, where should I start drawing the graph? Is the question. Can I start increasing from over here?
Start at 1.
Why at 1?
Because that's the asymptote.
Do I start below it or above it?
It crosses the horizontal.
Above it. So you're going to start above it, but in my head I think it's
No.
above.
You start above it. That's always increasing concave up.
Wait, if you want to see if it,
Then how do you know that 0, 0 is the max?
It's a relative max, right? For all points close to it, it's the highest.
wait, if you want to see if it crosses the,
Okay, so let's say why I knew it was up here. I knew it couldn't be down here because of what? I know it's increasing, right? Which means if it's increasing, it would have passed the x-axis, and then I would have another x-intercept. I know it doesn't have another x-intercept, so it couldn't be down here.
okay, so why weren't you so concerned?
It couldn't be here. Why couldn't it be here? Because let's say I'm here and I'm increasing to do that. I know the horizontal asymptote is 1, which means if I'm here and doing that, eventually I have to come back here to settle at 1.
Why?
Because it's a horizontal asymptote.
Oh, you have to.
I have to settle at 1 as I'm going out to infinity. So if I'm start below 1 to do this, I have to go increase to go back to settle here. And what would that mean? I end up with a minimum. But I know there's no minimum, so I couldn't start below either. I have to start above. It's the only one that matches all the information.
Okay, but if you wanted to find out if it,
You could also check if it crosses the horizontal asymptote by seeing if the function is ever equal to 1. Right? So if you want to see if it crosses this, you can actually solve for it. Plug in the function x squared over x squared minus 4 equals 1. You'll realize this has no solution, right? Because this would mean x squared is equal to x squared minus 4, which would mean 0 equals minus 4, which is absurd. So the function is never actually equal to 1. So I know it can't cross this line. So I can't be below it, so I have to be above it. So I know I start above this line, I'm increasing concave up. I'm above this line, I'm decreasing concave up. So this is what the graph would look like. Yes, you'll definitely have a first section problem. And it'll be one where you have to find asymptotes and intercepts. And I'm pretty sure that things like this won't happen. I'm pretty sure that you have something for everything. But maybe not. You look up in there.
Because there's a fact that any of these other two because they're not included. Is that why you drew it smaller? But if they were included, would you make like a bigger parabola on the bottom?
What do you mean?
So like the reason that it's not bigger
I can't cross this line
because they're not included.
because they're not included.
So let's say it wasn't included. And I know that's hard to think about, but like let's just say negative 2 and 2 were included and like nothing above 1, above 0 was included. Can you make it bigger for parabola?
Yeah, like you would be able to move over there.
Okay.
So, any other questions on first section? Let's do linear approximation.
What time do you guys want to do this?
You guys have to- want to use linear approximation to approximate this function. Right here answer as a fraction. What?
I don't know what that is.
Jackson, you know how to do it?
I really don't remember this whole approximation thing.
Like left it blank on the test. Like what? Goodbye.
Okay. So first, when you want to approximate a number and they say use linear approximation or differentials, you have to come up with a function that you can use. Here I come up with a function. Right? I want something that would look like what I'm trying to evaluate. So if it has squares in it, make it x squared. If it has cubes in it, x cubed. If it has a radical x, right?
What do you mean if it has squares in it? Like if the number is a perfect square?
Yeah. Just remember, wherever the number is that you want to figure out, replace that with x pretty much.
Okay.
Okay. Now, there are two other numbers that you're going to need. Remember, x is the number you actually want to approximate it at. And a is a number very close to x that you would know what the value is, which is 4, right? Because if that was a 4, it's easy, right? If it was 2, I get a half, right? So 4, I would know, and it's very close to 0.01, relatively speaking, right? And then we use the formula. This is the linear approximation formula. F of x is approximately equal to, in this case, f of a plus f prime of a times x minus a, when x is close to a. So I'm going to use this formula to figure out what its approximately is, right? So there's an ugly number I want to evaluate the function at. I want to approximate it using a nice number that I know how to evaluate that's close to this ugly number. There are no ugly numbers, but you get them. Did you guys see the proof that there's no uninteresting number?
What?
That there's no uninteresting number?
There's no uninteresting number.
All right.
Is that an inside
Okay.
joke from that?
So that's the idea. So I'm going to want to do a function for this. So I want my function to look like the thing I was going to evaluate. So this is why I make my function. I'm going to need to find the derivative. So let's start there. F prime of x would be equal to what?
-1/2 x.
Well, I can rewrite, if it makes it easier for you, you can rewrite the function, right? So I know f prime of x is -1/2 x to the minus 0 2, right? Which is -1/2 times the square root of x cubed. So now, this guy, what I want to evaluate, is actually equal to f of 4.01. That's like my f of x. This would be approximately equal to f of 4 plus f prime of 4 times 4.01 minus 4. Right?
Wait, hold on. So f of the actual number.
The actual number is x, the nice number is a x minus a.
Okay.
Right? I'm just following the formula. But remember, f of 4 is a nice number. F of 4 is just what?
1/2.
1/2, right? It's 1 radical 4. Plus, f prime of 4 is you just plug in 4 here. So it's -1/2 times radical 4, and you cube that. And this one would be 0.01. So now we're going to start to evaluate. This is just 1/2 minus, radical 4 is 2, cube that you get 8, times 2 you get 16. So this is just 1/16. 0.01 is 1/100. So this is 1/2 minus 1 over 1600. They said the right answer is a fraction, so we have to simplify this. So this, a half is the same as what?
800.
800 over 1600, right? So it's 800 minus 1, 799 over 1600. You're gonna have to go over the YouTube video and link links to different kinds of problems. Okay, if your problem is optimization, start at this. If your problem is curve sketching, start at this one. Yeah, that's that. That's 11.
Is the approximation used in something else? They're just going to ask this one question.
Yeah, they're gonna add something that's similar to this. Just use linear approximation to approximate some number.
So the second part of the final is the questions that we can choose which one we want to do.
Yeah.
So
I think there are 7 compulsory ones, and then you choose 3 optional ones.
And if you can do more than 2, you get extra credit? Is there any extra credit?
There's no extra credit on the final, no bonus or extra credit. What I will do though, if you do more than you have to, I'll give you credit for the best ones, like the ones you do the best at. But other than that, I can't give you extra points. Okay. I think I actually took this question from an old final. F double prime is 48x squared plus 6x plus 2. We know that f of 1 is 4. We know that f prime of 1 is minus 5. Find f of x. How do you find f of x? Integral, right. We want to undo the derivatives, right? We have 2 of them, so it means we're going to have to integrate twice.
Oh, this is the C and D stuff.
Right, so this was the C and D stuff she was talking about. But you can solve for one right away. So we know I have the double prime, I can get to the single prime by just integrating this. You add 1 to the power divided by the new power, right? So this is x cubed, this is 1/16, right? Plus 3x squared plus 2x plus c, right? And how do I find that c? I use the given information. Right? Now, this means that f prime at 1 is just minus 5. But that is, I just put in 1 for all the x's. So now I can actually solve for c. C would be minus 5, minus 16, minus 3, minus 2. Right? So c would be what? Minus 5, minus 3, minus 2, that's minus 10, so this is minus 26. So this means f prime of x is 16x cubed plus 3x squared plus 2x minus 26.
What? Oh, you just added it.
I just replaced the c here. And then I do it again, right? So I went from f double prime to f single prime, and now I'm going to go to f by integrating the single prime.
X to the fourth
4x to the 4th plus Or you can put plus D if you want to put C and D. Because we need that to get C and D. And now I use the fact that F evaluated at 1 is equal to 4. Well, that's just equal to plugging in 1 here. So it's 4 times 1 plus 1 cubed plus 1 squared minus 26 times 1 plus C. So this would mean my C is equal to that 4 minus 4 minus 1 minus 1 plus 26. 4 minus 4, that's 24. So finally, f of x is just this guy plus 4x to the 4th plus x cubed plus x squared minus 26x plus 24. So given the second derivative, I can integrate once to get the first derivative, and then I integrate again to get the original function. And these guys just help us figure out what the plus c is at each step.
So that's what it means? Going to general formula means finding the original?
The original, yes.
Why aren't you putting capital up?
Where capital?
When you do antiderivative, aren't you supposed to capital up to differentiate things?
Not necessarily. So that you have to know how to do. Part B to this question was you know f of x is equal to 0 to sine x and t squared plus radical t. They gave you a limit for x, but it's of no concern to us. Find f prime of x and f prime radical. So here we use the second fundamental theorem of calculus. How do you find f prime of x?
Oh, is that just t squared plus rad cubed?
Remember, you have a function on this unit.
Do
You have a constant down here, you have a function on top.
So do you actually take the integral or do you just, so sine x squared?
You just take the function, plug it in for all the t's, and multiply by the derivative. So this is just sine x squared plus radical sine x, and all that times the derivative. Right? This is where we use f of x equals the integral from a constant to x of a function. Then the derivative is just the function when you plug in the x. Or with the chain rule, is what we need here. You have a constant plus some other function on top. And what you do is you plug in that function and multiply by its derivative. That's called the second fundamental theorem. So if you have something like this, you just take this, put it in here. This is when you're differentiating, right? To differentiate, you don't have to integrate, right? Differentiating the integral is just giving back the original thing. So you get back this original thing, you plug in this limit. And you multiply by that because of the chain.
Do you minus the zero part?
No. Because it's a derivative. Plugging in 0 will give you a constant. When you differentiate it, the constant will die. So you don't worry about the constant. So now f prime power 4, you just plug in power 4. So this is sine power 4. Plus radical sine power 4 times cosine power 4. Sine power 4 is radical 2 over 2 plus the radical 2 over 2 times cosine is radical 2 over 2.
The radical 2 is the fourth root of 2?
Yes. But I wouldn't worry about something like that. Just do it yourself. Limits! Yay, limits! Everyone loves limits! I think limits was the favorite topic of the whole class.
We fully went through it.
Because it's the easiest.
Because what?
We fully went through it and like made sure that everybody understood it perfectly.
Limits are important. That's why we have to do that. Value limits. Limit as x approaches 3. How do you do that?
Factor to the top.
X plus
Factor to the top. Right? Remember, the first thing you always try to do is plug in that number, but the denominator is 0, so I can't. So then I think, can I simplify to get rid of the problem? And yes, to get 12, it's 4 and 3. To get plus, I need a plus here and minus here. So this would cancel, and now I can plug in the 3, right? So that's just
everything is
yeah, right?
You don't wish everything was this easy. You like the complicated.
No, because I get bored after a while. It's easy for you guys to say, because then you do 2 math classes and you never have to do math ever. Like,
We chose this.
I have to do math all the time, so I can't have everything be easy. I would like be bored out of my mind.
Oh.
Can you imagine year after year doing just that?
That's what they do in high school.
English thought process.
Same things over and over.
Why would you want your life to be hard?
I don't mind that to be hard. I want it to be interesting.
Talent, yeah.
What about this?
Oh, never mind.
Plug in 0 first.
Just plug in 0, right?
Ah!
There's nothing that prevents me from plugging in 0.
Oh, it's cosine of pi.
I feel
Right?
so accomplished right now.
I just plug in 0. Right? There's nothing to stop me from doing that. That's just 0. The 2's would cancel, right? So this would be cosine of 2 pi over 2.
We should get formulas.
Cosine of pi,
Why did the semester look like this?
which is
Cosine of pi is 1, 0,
no,
90.
no,
Oh, it's
minus
negative
1.
Oh my god, I said 1 first.
Minus 1.
So much.
That's like totally wrong. I think it's like 0 for the whole problem. You put 1.
You wouldn't have given me any points?
Nope.
What? I
Wow.
showed my work though. You know, like it was a minor
I
mistake.
showed my work. This is my
No, it
work.
wasn't a big deal. Maybe you didn't see the minus.
Like, what? I read it right there. That's the sort of thing that you scratch it while you're reviewing it. That's how I have to watch you when you're reviewing your final.
We're doing our final?
When you're reviewing your final.
Oh.
That's one.
What if we review it away from you?
No, I sit there and watch you. I don't want you to like write
we
a
don't-
minus sign.
What if it was like faintly there and I like erased it and I was like, look, it's right there.
You erased it, it's not there. What's this?
You can hold something.
3 minus 2.
1? Why is it 1?
Because the
Going to infinity,
2.
the
Okay.
highest powers are the same. Just goes to the ratio of the coefficients.
Oh, right, that's
Right? No, when the highest power is on the bottom, it goes to 0. If the highest power is on top, it goes to plus or minus infinity. You just have to watch the signs.
But is it ever a number? There was one time it was like 3.
Yeah, like if I had 3x squared on top, the answer would be 3.
What sign of 0?
Sine of 0 is 0.
Cosine of 0 is 1.
That is correct. How do you do that?
Everything gets mixed up.
You split
Oh,
it sine 4x over 1 times 1 over sine.
Oh no, yeah, right.
Yeah, split it up, right? Sine 4x over 1.
That's on the
Equals
test.
sine 6x. And how do you do those?
Equals that, so it's
You
4 over
multiply
4
sine
times
4x
6
plus 4 square.
4x over 4x, right? And then you multiply by 6x over 6x. Right? Because remember the rule we're trying to use.
Did some people already say fine?
No.
Everybody's saying fine on Monday?
The department's final is on Monday. Yes. We're using the fact that sine x over x gives us 1, and so does x over sine x. So the angle has to be the same as the denominator. So here the angle is 4x. So I need the denominator to be 4x, so what I do multiply by 4x over 4x, and so this guy I can shift him over here. This guy I can shift him over here. So what I really have now is the limit as x approaches 0 of sine 4x over 4x times 6x over sine 6x times, here I do that with 4 over 6. And so this, because the angle is the same as the denominator, goes to 1. Angle is the same as the numerator, goes to 1. And so overall, the answer is 4 over 6, which is 2 over 3.
Wait, you said if the top, on number C, if the top is higher, if the top
It
is
goes
bigger
to
than
plus
the
or
bottom,
minus infinity.
plus or minus.
Yeah.
So how do you know if it's plus or minus?
You look at the signs. So if I
X
had
to the third over x squared would be positive.
right, so if I had like x to the third over x squared plus something, right? This would go to positive infinity. If I change this limit to negative infinity though, then it would go to negative infinity. Because I'd have a negative number cubed, which gives me negative. And squaring it keeps positive, so it would change the sign.
But if it was x squared over x to the third, then it's 0.
Right. If it was x squared up here, x squared down here is 0. So when it's the top is bigger, you have to be careful with the signs. You have to think, am I plugging in a positive number or a negative number? How is it going to change things? Huh?
This one's actually hard because you can't separate the denominator. No, I'm never mind. I was talking about this next question.
E? This is x squared over sine 3x times tangent 5x. Here we can use the additional information. Remember, this that was true for sine is true for tangent as well. Right? Limit as x equals to 0, tan x over x is 1.
What about for cosine?
The one with cosine is 1 minus cosine x over x. As x approaches 0. That's 0.
That's like sine of x over x, right? That rule.
Yes, this is one of those special trig limits. We also have that the limit as x approaches 0 of tan x over x is 1. And again, once the angle is the same as the denominator and they're both going to 0, that would be true. So I can use that to my advantage here. How would we do it?
So it's x over sine of x times
Use
x
separate
over.
all. So it'll be x squared.
Right, no, the x squared, remember I can write it as x times x.
But you can't separate the denominator.
So this is x times over sine 3x times
What?
x over 10.
I remember you saying that you can't separate the denominator.
I didn't separate the denominator, they're still being multiplied.
If they're a plus, then.
Oh, that's
If they're a plus, I couldn't do it. If this was a plus here, I couldn't put a plus here, that would be wrong. But they're still being multiplied, so that can work.
You're gonna multiply by 3.
Times three.
So I need 3 over 3, right? And here I need 5 over 5, right? So this part here is going to go to 1.
So it's 1 over 15.
This part here is going to go to 1. So it's 1 divided by 3 times 5.
So we're not gonna have these speed and velocity and that stuff?
I did, but I just wanted to do a different example.
A stove.
Because that problem is too nice. I might put something like that on the wrong phone. So don't look at it.
Why would you drop a
You should just show
stone?
us how to do that.
We dropped a stone from the tower
Oh,
because
thought you said
I
a
want
stone. I thought you said a stone. I was like, why would you drop a stone?
to. No, it's a stone.
Should be, that'd be funny.
Sure, we could drop a stone.
Then you have to find out the weight of it and, you know, the measurements of the stove, right?
Yeah.
Yeah, really? Oh my god.
No, you.
No, in high school, you have to hear this. I used to ask everybody. So an elephant jumps off a building, and a mattress. An elephant jumps off a building, and a mattress comes out on one of the floors, right, while it's jumping off. So the elephant's coming off, and the mattress comes out. So while he's falling, and then he lands on the mattress, does the mattress go like this, or does it go straight down?
It goes straight down because the elephant's heavier. Wait, does the elephant touch the mattress?
Wait, what is the mattress on?
It's not nothing.
Like on
Air.
wheels or?
Air.
It's on air.
So yeah, someone pushes the mattress out, and he lands on it. Does he go straight down, or does he go straight forward?
The elephant is going like this or falling straight down.
He was going falling straight down,
Wait a
and
minute.
he lands on the mattress.
Elephants.
The mattress was like pushed out with great force.
The elephant pushes the mattress down.
Elephants
The
can't
elephant's
jump.
heavier.
Everybody, it's your own opinion, but it really makes you think. So
It's your own
yeah, you don't know. You don't know how much. You don't know how much the elephant weighs. You don't know how
An
when he
average
landed on the
elephant weighs like
mattress.
a few tons.
Unless someone's throwing that out.
The mattress is going straight, and the elephant's coming down. So when they come in contact, does he go like this, or does he go straight down?
Goes like that.
It's not gonna change like the mattress. What? No, the mattress is like it weighs like nothing compared to the elephant's weight, so it's not gonna change the direction of where it's going.
Is it?
Yes, it will.
Did you say physics? Remember?
Physics.
If
The
you
physics
throw a
vectors,
pen in
right?
the air, or if you throw, wait, what was it? It was like, oh, the example was if you shoot a monkey from a slingshot, right?
Oh my god!
No, this is the example the teacher used. Then it goes straight. If you go to the other side, you're gonna catch it. You get it?
What?
If you throw the monkey from a slingshot, and you go to the other side, and you run to the other side at a certain speed, you're gonna catch the monkey. Get it?
Okay, that's like a whole different thing.
It's so
But it would
serious.
move diagonally. Think of it because the elephant is moving in this direction and the mattress is moving in that direction.
The elephant wasn't moving
Yeah.
that direction. The elephant was
It was
moving
going
straight
straight.
down.
The elephant is going straight down.
Yes.
Yeah, the mattress is not going
But the mattress
move
was
that
pushed
way.
out with great force.
So it's definitely going to go in the diagonal.
What? Okay, the mattress doesn't weigh. It doesn't weigh.
Because if you add this vector to that vector, you get a vector that
But that
goes
vector
this.
is like practically nothing compared to that vector.
Right, it's going to be very small. It's going to
Oh,
be,
yeah.
if this is the vertical, it's
You
going to be
won't
like
notice it.
that. It's going to be very
Yeah, you
small.
won't notice it.
But it is going to go in that direction a little bit.
Anyway.
Anyway, next thing we're going to start throwing pandas in front of cars. I don't want to hurt any more animals, okay? I just want to
Just one third stoves.
just those, just on those slopes of the CN tower that's 450 feet above the ground.
Oh my god.
Okay, so it's dropped from the top of the tower that's 450 feet. Find the position.
Why
So-
get rid of your question? The 96 as your favorite number. Oh, you're gonna put up tomorrow's one.
Because 96 is not my favorite number. I was like, what's, this is a lie.
You wrote it. You wrote it. There must be a reason you wrote it. On the first day of class next semester, you're gonna find 96 all over before. No, I'm not gonna do that. I'm joking.
You're not in my class. You're not in my class. You know what time you even register.
I'm not. I know, but I'm gonna come. Not always though. I
Find the
have
position and center.
I'm a little bit-
How do you do this one? So what they don't tell you in problems like this is gravity is the acceleration. You start with acceleration.
Gravity
Right.
is the acceleration.
So for free fall, so this is called a free fall problem. Free fall, and start with gravity. For whatever force is pulling you down. And remember, this we know is minus 32 feet per second squared, or minus 9.8 meters per second.
They won't give you this on the exam?
No.
Are you serious? Like, what if someone never?
Like, if it's just the gravity of Earth, they expect you to know these values. There are times when they might make up a problem and tell you. So they're like, pretend you're on a planet Z naught, right, where gravity is this. You know, what's the law?
So you can't use the meters per second one for this.
No, because here it's feet, right? So here we know we have feet, so I have to use this one. So I know I start with acceleration, because gravity is the force of acceleration. Gravity causes acceleration, so we start with minus 32. Then we want to go from acceleration to position, because that's what the axis for. So the next thing we go to is velocity, remember? Which is what? What's velocity?
At time 0, it's 0? That doesn't make sense.
Minus 32. That's supposed to be.
Like those are facts,
It's
right?
an antiderivative of acceleration. Right? Remember when we had s of t, if you, is position, you have to remember v of t is equal to s prime, which is velocity. Right? And a is v prime, which is acceleration. So to go down, you have to differentiate. And to go up, you integrate. Right? That's what you have to remember for these problems. So if I'm starting at A and I want to get to S, I have to integrate and integrate. So I'm going to anti-differentiate this. So this is minus 32 dt. This is minus 32 t plus c. Can I find that c?
If you at 0, it's 0,
Right. You know, since v of 0 is 0, we have that minus 32 times 0 plus c is 0. So c is 0. How do I know v of 0 is 0? Because it's dropped. Right? That's drop just means someone's holding it and lets it go. So in the beginning, it's not moving at all. Again, that's more language from physics. When they say dropped, they mean initially was the speed was 0.
There's only one problem like this, right?
Well, if a problem like this comes on, there will only be one of them, yes. Okay. So this means that your v of t is just minus 32t, right? Because c is 0. So now if I go to position, it's just an antiderivative of minus 32t t. This is minus 16t squared plus c. to what? What's the initial position?
450.
450, right? Because we drop it off the top of a 450 foot tall building. So this means when I plug in 0 into this function, the answer is 450. This means C is 450. And this means that the position is S of t equals minus 16t squared plus 450. That's the answer to part 8.
Oh, wait, is there a form that we could remember this by? With the steps that you took and all that?
Yeah.
Well, yeah, I mean, for free fall, the position is always given by a over 2t squared plus b0 times t plus s0. Where a represents acceleration, v0 constant acceleration, v0 is initial velocity, and s0 is initial position. And this is minus. With the convention that down is the negative direction, up is the positive direction, I need this minus. So knowing that, I would have put 32 here, 0 here, and 450 here, and I would have gotten this. But again, like, this is a form you get in physics, but you have to remember it's a very specific situation. This is just for free fall. Something is just falling in a vertical thing, and the only force acting on it is gravity.
Would they give us something that would like throw like a thingy when it first go from
In Calc 2. In Calc 2, then that's where you shoot monkeys out of slingshots. They'll say, you know, projectiles is launched at this angle, you know, how far will it land and things like
That's
that.
so
Wasn't
weird.
that
Why would
the
you come
example?
up with
That
that?
was still the example. Or was it a tennis ball? No, the tennis
There
ball
was,
thrown on the
no,
floor.
there were no monkeys. We don't hurt animals in that. I don't know what you guys are doing in
What about
physics.
physics?
We would shoot a cannonball
Yeah,
or
why would
an
you,
object
like,
or a projectile. We're gonna
Come
shoot a
up with
monkey.
that. Like, why would you just? Oh, let me just shoot a freaking monkey out of a
You
slingshot.
can never hurt that.
You know why? Because all the problems are too easy. Physics professors start getting bored, so they start making
Monkeys.
See, this is why you need harder problems, because then professors start turning like, crazy.
You should make a new theorem, Von theorem, or something. I don't know. Come up with something new.
How long does it take to hit the ground? How do you figure that out?
Oh, do we need to know any theorems?
Just take.
Like, do you need to memorize any of them?
You need to know all the theorems I taught
Do
you.
you plug in?
No way. No, for the final. No, for like.
You set the position to 0.
Set position 0. Hit ground means S of t equals 0. This means minus 16t squared plus 450 equals 0. This means t squared is equal to minus 450 over minus 16, which is 450 over 16. So t is equal to the radical of 450 over 16. Plus or minus, but we take negative time to be nonsensical, so we just take a positive radical. And does this simplify at all? I don't really think so. Does 4 go into 450?
Yes.
1,
No.
it doesn't. This is 1, 0, and this would be, yeah, it wouldn't go in exactly. divide by 2, but 2 equals 2, 5. Okay. C. With what velocity does it hit the ground?
Do you plug that time into the velocity?
Right, you just take v of this number, 225 over 8. That's the velocity that it hits the ground. So it's just minus 32 times the radical 225 over 8. Velocity with which it hits ground.
There wasn't any optimization problems.
Yes, there is.
Oh.
I just didn't get to it yet.
Oh.
Problem 15. See the light at the end of the tunnel. Find the average value. Average value of x equals the cube root of x on 1/8. Taken from the textbook, section 4.4, problem 15. This is asking for f average. What's the formula for f average?
1 over b minus a.
1 over b minus a times the integral from a to b of f of x. Right? Where this a, b is just a notation for the endpoints of the integral. So this is 1 over 8 minus 1 times the antiderivative of 1/8 of the cube root of x. It's 1 over 7, it's 1 to 8, of x to the 1/3. So the antiderivative of that is you add 1 to the power 4/3, divide by the new power, which is 3/4, between 1 and 8. So it's 3 over 4 7s 28. X to the 4 is 3, between 1 and 8. And what you do is you plug in the 8, minus you plug in the 1 for x. What's 8 to the 4/3?
Don't look at me.
What's 8 to the 4/3?
I don't know.
Looking at you. What's 8 to the 4/3?
The cube root of 8 to the 4th, which is
Right. Cube root of 8.
16 times 16 is
Cube root of 8 is 2 to the 4th.
Oh, you can do that?
yeah.
So that's just
What?
16.
Seriously? You can just
But
ignore the
no,
power.
the whole thing isn't to the 4th.
You just ignore the power and take the radical.
No, 8 to the 4/3. This is the same as 8 to the 1/3 raised to the 4th. 8 to the 1/3 is 2 to the 4th is 16. So this just gives you 15 times 3 over 28. And 3 times 15 is 45 over 28. Alright, so that's about average value, it's just that formula. So you just plug in that formula and do the definite integral. Riemann sums. One, two, approximate 1 to 2 of x squared plus 4x plus 1 dx. So I need 4 subintervals, right-hand endpoints. How do we do it? So I want to go from 1 to 2. And I want to split that into 4 parts. How do I find the parts?
Oh, that's so fun. So, you find the middle. The middle is 1.5. And then the 2 other ones are 1.75 and 1.25. Right?
The middle is 3 halves.
Yes, the middle is 3 halves.
Which is 1.5.
What would this be?
Okay. So that would be like 7 over 2. I don't know how much it is and stuff.
Well, remember you start by finding the delta x. What is the delta x? Remember it's b minus a over n. B is 2, a is 1, and is 4, right?
Yeah. That's 1/2.
So it's just 1/4. So this would be 1 plus 1/4, right, to get to here, which is 5 over 4. And then you add again 1/4. You would get what?
So
You get 6 over 4, which is 3 over 2. You add 1/4,
7.
you get 7 over 4. Right? And now since we're using the right-hand endpoints, it means we care about this, 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 and that. And so the area would be approximately equal to delta x times f of 5 over 4 plus f of 3 over 2 plus f of 7 over 4 plus f over 2. So this is 1/4 times 5 over 4 squared plus 4 times 5 over 4 plus 1 plus and that's what it is.
Can you do the one with the limits? The exact. Are we
But
gonna
this
go
one,
through those?
no, it wouldn't be that crazy. We can do it, but
Can you like give an example? Just like a simple one.
you mean like, let's say you wanted to do, like the simple ones would start at 0. This is 0.
Since it says right-hand points, like if it doesn't say that, it just says right-hand sum to 5.3, or is that
No, they'll have to tell you how they want it.
but they might tell you like A, B, C, do the whole thing.
Or they might say left-hand endpoints, or they might say midpoints, or something. So we did something like this scenario. This is easier. So if you want to use a Riemann sum, the exact answer, what you just do is the formula is the limit as n approaches to infinity of the sum from 1 to n of f of a plus I delta x times delta x. So here your delta x equals b minus a over n. So that's just what?
This is where I fell.
Oh, that's why you're, yeah, you fell asleep. Deja vu. And then your a plus I delta x would be, your a is 0 plus I times 2 over n. So that would just be 2I over n.
So we don't use B here? No.
Not here, no. So your a will equal to the limit as n goes to infinity of sum from 1 to n Now you take f of this number, but that's 2I over n, so you plug that into the f of x. So this is 2I over n, and you square that, times your delta x. That's yours.
Oh,
I don't know if it's an emergency. Okay. Times the delta x, which is 2 over n. And then you'd simplify that. You should notice that this you can write as 4 over n squared times I squared times 2 over n. So you can factor that guy out. This is 8 over n cubed. Limit n goes to infinity of 8 over n cubed times the sum of I squared. And that's when you plug in the formula. 8 over n cubed times the sum of I squared is what? N times n plus 1 times 2n plus 1 over 6. So this would go through the ratio of the coefficients because you have n cubed over n cubed. And so this just goes to 16 over 6. So it's actually 8 over 3. Let's just, this is the formula. You just sort of plug this into your function, multiply by delta x, simplify. You're going to get one of those guys we told you about, i's or I squared or I cubed. Replace that with the formula, and then take the limit. I'm not sure if that will come on, though. It's been a while since that came on. I meant to ask this earlier, but I forgot until the end, so I just threw it in here. 17. You guys should be able to answer this, though.
That's good though, you might do that.
oh,
Alright, so where's the slope of the tangent line to this graph equal to 10?
just derivative,
Find the derivative.
2x plus 3. And then,
So the slope equals 10
oh,
if 2x plus 2 equals 10, right? Which means that your x must be 4, right? So slope is 10 at the point 4, comma, that would be 16 plus 8, 24. Right? So that's it. So they ask you, where is the slope equal to something? You find the derivative, you set it equal to that thing, and solve for the x values. What is the tangent line at this point?
oh, y minus,
Y minus y1 equals n, x minus x1. So this is y minus the y value, I know is 24. The slope is 10. And the x value is 4.
I actually didn't understand the question at first, because they were looking for a point. Where?
Yeah, where is our point? This was the answer. The slope is 10 at this point. And at that point, the tangent line is this.
Could they ask something else? Like not where, but like, I don't know.
Like, to make a problem like this harder, what they might do is they might compare it to another function. So they might say, where's the slope of this function equal to the slope of this function at this point? So you have to work around this function, figure out what the slope is, and then find the derivative here set equal to that number. They could do something like that. What is the area of the largest rectangle that can be inscribed in a circle? This is an optimization because it talks about making something as large as possible.
What if it was as small as possible?
It would still be optimization, right? Same process except you look for the minimum instead of the maximum. So this is sort of a weird problem that we haven't really done anything like it really. So I have a circle. I want to figure out what's the biggest rectangle I can draw inside this circle.
The area, because that is the biggest rectangle.
Yes, you want to maximize the area of the rectangle. Right?
So the circle's area, its radius is 2.
Yes, we have this. This radius is 2.
So
So
What?
what?
I don't know.
Where'd you get
Because I was going to say like this
The circle is
part.
x squared equals x squared plus y squared equals.
This is 2, 2. Which means in the right triangle, the hypotenuse is 2.
This is always 2, right? But the thing is, there are many different rectangles you could draw, right? I can draw one like this, right? Or one that's wider. Like how do I know which one is the biggest one possible?
Takes up the most
So
space.
area?
The one that takes up the most space. I want to find the biggest area. So if you see a problem like this, one nice thing to do is to like break it into a smaller chunk. Notice that if I concentrate on here, right? If I make this area the biggest, all the other overall area will be the biggest, right? Because it's all symmetrical. So if I sort of zoom in,
But you get a weird shape.
I'd have a quarter of a circle, and then there'd be a rectangle here and here. And I want to make that as big as possible. Right? So I know that this will have some width. It would also have some height, right? I need to know what are the best ones to choose. Right?
You're not going to use the hypotenuse then? It's not the best way to do it. Or you can't do that. That's wrong.
How do you use the hypotenuse?
So then x squared plus y squared equals 2 squared. You know what I'm saying?
So, like that.
Yeah.
And you want to maximize the area of the rectangle. X squared plus y squared equals 2 squared.
Like 1 and 1.
Well, you could do that, but what would happen? The thing is, how do you differentiate x squared plus y squared equals 2 squared? Because it's that, you can't really differentiate that.
For this problem.
Unless you solve for the y, and then do it that way, you could do it that way. But then the area would be half times the base times the height. And then you double that. Or, I think you'd end up at the same place where I'm going when you work it all out. So we know that the area is x times y, right? This is our objective. What's the constraint here? It turns out that the height is a constraint. I can actually solve for y, right? The height of this cannot pass the circle. The circle is the restriction, right? No matter where I am, my height stops here, right? So the height of the circle is the height I have to be. But what's the equation of the circle, this part?
1/4 of r squared? Wait, what?
The equation, not the area. If my x squared plus y squared is equal to 4, what would y equal to? Y would be 4 minus x squared, and then you take the square root, right? Plus or minus, but I only have the positive part here, so I don't worry about the minus. I'll get to the minuses in a second. But this is the constraint. Right? My height has to be given by this number.
Is the problem on the test going to be this hard?
They're all numbers. They're all
This is like beyond hard.
They're all
like
numbers.
hard.
But once you can think about something like this, you'll be able to do the problem and test and no problem, and you'll be fine. So,
Wait, so the x squared plus y squared whole squared, what does that actually represent?
that's the equation of the circle.
So the circumference. Wait, so the...
No, the equation that gives you all the points on the circle,
Oh.
right? Which means I can solve for the y in this. I get a plus or minus square, but since I don't care about the top, I don't care about the plus one. And so now this is a constraint, which means I can plug the constraint into my objective. I can take this, put it here. So this was the picture trying to figure out the problem. I know my objective was to get to area. I had to figure out the constraint. Turns out my constraint is the height of this rectangle because I can't pass the circle. So I figured out what's the equation that gives us the height. Well, it's this one. Just solve for y in the equation of the circle. So that's the constraint. Plug it into the objective. I obtain this. And now what do I do? Once I can write my objective into one variable, what do I do next?
You try to solve for one of them.
Yes, but solve what for one?
You could solve for
The next thing is to differentiate. Remember, we want to make something as large or small as possible, which means we need to find a maximum or a minimum. To do that, we need to find the derivative. So I find the derivative. What's the derivative of this? Go back to problem one.
one
Radical
times.
x.
Yeah, 1 times this.
Yeah. Plus
We have the x times.
1/2 minus x squared to the negative 1/2.
2x minus 2x.
Right, so this cancels that.
The x is canceled here. No,
No, they multiply.
2x, yeah.
So I can factor out 4 minus x squared to the minus 1/2. I would be left with 4 minus x squared. Just want to simplify a little bit. Minus x squared. So this is just 4 minus 2x squared over 4 minus x squared. Right? That's the area. The derivative of the area.
You brought the thing that's not.
Yeah, this is a common term. So I factored it out, factored out the lowest power. I'd be left with, in the first term, I'd be left with 2 minus half, so I'd be left with 1 here, right? Because when you multiply minus half plus 1, it gives me plus a half. Then this guy is just gone.
So you brought that to the bottom.
And this negative a half, I brought to the bottom, yes.
And you, how'd you get rid of the minus x squared?
Minus x squared, minus x squared, minus 2x.
Plus God.
So now, set a prime equals 0, right? Because where it's undefined, it won't work. So this means 4 minus 2x squared equals 0. So your x would be what? Radical 2. Technically plus or minus, but the minus, of course, doesn't work because I'm looking at a positive x value. This means the y value would have to be what? Y is actually 4 minus x squared. So that's just 4 minus radical 2 squared. That's just radical 2 as well. So this means in my circle, this length would have to be radical 2, and this length would have to be radical 2 to get the biggest possible rectangle. Right?
So say it's 3.
So overall, the height of my rectangle has to be 2 radical 2's, and the width of this has to be 2 radical 2's. So the largest area is x times the length times width. 2 radical 2 times 2 radical 2. This is 8.
So is optimization one of the problems that we have to do?
No, optimization is usually the choosing section.
Thank God. I
Well,
am not going to be able to do it.
Huh?
All of what? I have some.
What about the related rates problem?
Related rates might be compulsory, might be optional. I don't remember. Know how to do at least one of them well. You should know both. Know how to do at least one of them. Because they'll never put both optimization related rates in one problem. So, if you know how to do one well, you
Wait,
trust
so
me.
would they put both related rates and the optimization on the test?
Yeah, every final will have both on. But you should be able to choose one as opposed to the other.
There's a limit, there's another, there's a limit, a continuation problem, F average, ratings on right now. Those are 5.
Yeah.
Not all.
Sometimes they ask you about continuity. I didn't really do an example like that, but maybe I'll put that on the mark. Anyway, you got it. Anyway, if you know how to do all these problems, you should be in good shape to pass the final. If you want to be perfect, get an awesome grade, you should try the mock final tomorrow. If you have that under control, then you're in
Oh,
golden
I wanted
shape.
to ask you about that. If you look at the spreadsheet, most of the people who said they want Saturday from 12 to 2, they wanted a review on Saturday from 12 to 2. I don't have a final. I have a final tomorrow from 12 to 2.
Oh,
That's
really?
weird.
Sorry, I didn't know.
Are you guys okay with after 2?
Yeah.
You two, you're okay? We're the people that came. Take our orders.
Take our orders, Javon.
Oh my god. Come on. While I'm taking, if I'm like, I could be taking math right now and discussing this and understanding.
You guys want your test?
No.
Yes.
I
Actually,
don't mind.
I'm gonna cry. I know I'm telling God.
Don't cry.
You don't have to take it. I'm not forcing you. You can take it after the final if you want.
No, it's okay.
You don't want to.
Oh wait, do I have to stop this?
Okay, yeah, you can stop.